This is Kusuma, Assistant Professor, Department of Mathematics, VNR VJT. Today I am going to tell very important topic, that is Fourier series. So Fourier series is a very helpful and crucial role electrical electronics fields such as signal processing, communications and image compression, all the audio compression, all the noise filtering, all the useful for Fourier series. Understanding the Fourier series helpful us to break down the complex periodic signal to sum of sine and cosine waveforms. So it is a compressed, it is a complex signal to easier simple. It is a make easier for designing and analysis purpose. So now today I will going to introduction on Fourier series. What is Fourier series? Here I will tell you what is the conditions for the Fourier series and some basic formulas. Now, Fourier series introduced by French physician Joseph Fourier is a mathematical tool decompose the periodic signal into sum of sine and cosine waves. So your complex periodic signal decompose into sum of sine and cosine waves. So it is example. So in the real life, in the signal processing, the analyzing the signal and manipulating the complex signal, the Fourier series analysis is very useful. And also include the audio compression, noise filtering, image compression in technology like speech recognition, all the techniques, the Fourier series analysis is very helpful. One example in the signal processing. So in the Fourier series, in the fundamental for analyzing the manipulating the signals, decomposing the signal into constitute frequencies, making it is easier to filter and compress or modify. For example, in this here these are signals. Here it is the one signal decomposed into two signals, sum of two signals, that is called sine and cosine waves. So for it decomposing for decomposing your easier your designing and analyzing purpose, the Fourier series and Fourier transforms are very useful. So the mainly the concept, the function, if it is periodic function, function or periodic waveform or periodic signals decomposed into sine and cosine waves, you are using Fourier series. Your function is non-periodic function, for that you can go for Fourier transforms. So here Fourier series Fourier, make it note Fourier series for periodic function, Fourier transform for non-periodic function. Next, I ask one question. Can any function be expressed as a Fourier series? Is it possible every function in the decompose into sum of the sine and cosine waves? Yes, but it is, if it is a periodic function, can represent as a Fourier series if it is satisfied Dirichlet conditions. If it is the function satisfied Dirichlet condition, you can express as a sum of sine and cosine waves. Now let us discuss what are Dirichlet conditions. So if you write the function in the form of sum of sine cosine waves, a0 by 2 plus a1 cos x plus a2 cos 2x plus b1 sin x plus b2 sin x in the interval c comma c plus 2l, satisfy the four condition. What is the first condition? The function must be periodic with the period 2l. Here consider the interval c to c plus 1. The length of the interval is 2l. In this interval, the function must be periodic. And second condition, the function f of x is finite and integral value of in this interval also finite, and also the function must be single valued function. The second condition must be satisfied. And third condition, What is the third condition? The function is piecewise continuous in the interval. Whatever you consider in the interval, this function must be piecewise continuous. So this is the third condition. And what is the fourth condition? F of x has finite number of maxima, minima in the interval c to c plus 1. These four conditions satisfy f of x in the interval c comma c plus 2l. Then the function can be expressed as sum of sine and cosine waves. So here clearly explain each and every condition. The first condition, what is the Dirichlet first condition? F of x is a periodic with the period 2l. This is the first condition. So before going to this condition, what is periodic function? Here I explain now what is periodic function. A function f of x is said to be periodic function if there exists a positive integer t such that f of x plus t is equal to f of x. This condition is satisfied, this function, then f of x is the periodic function, and also this t is the smallest positive real number, then this is called as a fundamental period of f of x. T is called as fundamental period of f of x. For example, here I consider the function f of x is equal to sin x. Sin x is my function. So now check whether it is a periodic function or not. There exists a positive integer t such that the condition is f of x plus t. Here sin is my function. Sin of x plus t, here 2 pi I consider. Sin of x plus 2 pi is equal to sin x. Sin of x plus 2 pi is equal to. So our condition is satisfied. What is the sin of x plus 2 pi value is sin x. Then sin x is called as periodic function with the period 2 pi. Similar manner, cos x. Cos of x plus 2 pi is equal to cos x. Then cos x is called as a periodic function. You know that in the level of intermediate, sin x and cos x, secant x, cosecant x as a periodic function with a 2 pi, and tan x and cot x as a periodic function with a period pi. This is a very well-known values. And the function sin nx and cos nx are also periodic function with a period 2 pi by n, while the fundamental period of is pi by n. So this is 2 pi by n is the sin x, cos x, secant x, sin nx, cos nx, secant nx, cosecant x. This is the first condition. So your function is periodic function. The condition must be satisfied in the period of 2n. Next, second condition. So second condition is Dirichlet condition number 2. F of x and its integrals are finite and single valued function in the interval c comma c plus 2l. Suppose, for example, f of x is equal to x square is the function. First, it is check f of x is the finite or not. You can consider x values any. The square of this one, the function is always finite one. So it takes some interval 0 comma 1 in this interval. In this interval, f of x is equal to x square. So so in this interval, this function is finite. F of x is finite. F of x is finite. In this interval, the integral value of f of x in this interval, it is 0 to 1 interval, the function f of x dx, integral 0 to 1 x square dx, it is equal to x cube by 3. It's 0 to 1. So upper limit is 1, 1 by 3 minus 0, answer is, it is also finite. The integral value is also finite in the interval. So the function is finite and integral value is also finite. The condition 1 is satisfied, condition 2 is satisfied, and what is the next one is integral is finite and f of x is finite and the function must be single value. So any domain, what is the domain 0 to 1 in this interval, the range of this function f of x also single. It is means you consider f of 1, the 1 square, it is the output is 1. So only map the domain to range is a single value. The function is called single value function. So this f of x is equal to x square satisfies the Dirichlet condition number 2 in the interval 0, 1. Next, one more example. Suppose we consider f of x is equal to 1 by x. F of x is equal to 1 by x in the interval 0, 0, 1. What is the f of 0 value? See that 1 by 0 is equal to infinite. 1 by 0 is equal to so. So the function f of x is not finite. So this Dirichlet condition is not satisfied. Here the f of x is equal to x square is the Dirichlet condition number 2 is satisfied, but f of x is equal to 1 by x is the Dirichlet condition number 1. 2 is not satisfied. Because f of 0 value is equal to 1 by 0, it is infinite. So the f of x value must be finite. And go for next condition. What is the next Dirichlet condition? F of x is the piecewise continuous in the interval c, c plus 2l. F of x is the piecewise continuous in the interval c, c plus 1. First, let me know what is piecewise continuous function. So the piecewise continuous function is in the interval a, b. If the interval can be subdivided into finite number of intervals. Each subinterval is continuous, and the left hand limit and right hand limits must be finite. So again I divide. So if the function is not a continuous function and each interval into subdivided into a finite number of intervals, each part of the interval must be. Suppose you observe that this figure, it is not a continuous function. So this is the one curve, another curve. It is breaking here. So this is a it is you have to see that whether check it is a piecewise continuous or not. So this piece must be continuous. This piece must be continuous, and also this is the right limit of this one. This curve must be finite, and this is a right limit. This is a right limit of this curve must be finite. And left, this is a discontinuous. Here also finite. These values must be finite. Left limit and right limit of wherever discontinuous the curve must be finite. These conditions are satisfied. This function is called piecewise continuous function. Once again, each piece must be continuous function and has a finite left and right hand limits. Finite left and right hand limits. These two conditions are satisfied. This function is called as piecewise continuous. For example, I take one example. F of x is equal to x and x less than 0. F of x is equal to 1, x less than or equal to 0. In this case, you draw the figure. The figure of f of x is equal to x is this one, and it is observed that x is equal to 1 is this one. So it is a check whether it is a piecewise continuous or not. So this part is continuous, x less than 0. This is the x greater than. How to check continuous? Left limit and right limit of the function, it is equal to the function value. These condition is satisfied. The function is called as continuous function. So this piece is continuous, this piece is continuous. Here the left and right hand limits are finite. This is the piecewise continuous. So it is, you observe that each piece has a finite jump. So this function is piecewise continuous. So one more example on a piecewise continuous function. So here example number 2, I take the function f of x is equal to 1 by x minus 1 whole square on the interval 0, 2. Let us draw the figure corresponding to this function. So you observe that here one piece. So here it's a break in your curve. So you observe that when you put x is equal to 1, this this is not a finite discontinuous. It is a infinite discontinuous. So put x is equal to 1, and that means f of 1 by 1 minus 1 whole square. So that is equal to 1 by 0. That is equal to infinite. So I said the function as infinite discontinuous at the point x is equal to 1. So it is a function is not bounded. Not bounded. So here the previous example, the functions are piecewise continuous, and also it is a bounded, and the left and right limits are finite. In the example number 2, this function is not bounded, so this is not a piecewise continuous. So I clearly explained that is a third condition is very important condition, that is called piecewise continuous. So what is piecewise continuous? Each subinterval of the function is continuous, and left and right limits are finite. These conditions are satisfied, the function is said to be piecewise continuous. Go for final last condition. The condition number f of x has a finite number of maxima and minima c comma c plus 2 in the interval. So I take the one graph here. This is the, you know that this is a sine wave. So in the interval 0 comma 2 pi. So here you observe that, so here the maximum value x is equal to pi by 2. Maximum value in the interval 0 comma 2 pi. So here consider finite interval 0 comma 2 pi. In this interval the maximum value x is equal to pi by 2, and minimum value x is equal to 3 pi by 2. So you observe that this function, and here function, what is function? F of x is equal to sine x function in the interval 0 comma 2 pi. So finite number of 1, extreme maximum 1, here maximum point 1, minimum point is 1. So finite number of maximum minimums in this. So this function f of x satisfies the Dirichlet condition 4. And one more example set. So here I consider the function f of x is equal to sine 1 by x in the interval 0 comma 1. Sine 1 by x in the interval. You observe that in the function minus 1 to n, here the steps, so infinite number of jumps. So the maximum is infinite and minimum is also infinite in this case. So the Dirichlet condition 4 is not satisfied for this function. Yes, sin x in the interval 0 comma 2 pi. Dirichlet condition number 4 is satisfied. What is Dirichlet condition number 4? F of x is the finite number of maxima and minimum in the interval c comma c plus 2 here. So here you observe that the second graph, it is it's a minus 1 to is infinite number of maximums minimums. So condition number 4 is not satisfied. So it is not this f of x is equal to sine 1 by x not expressed as Fourier series series expansion. So I clearly explain here the condition 4. What are the conditions? The condition number 1, the function must be periodic function. F of x is a periodic function. Periodic function in the interval. So you consider some interval c comma c plus 2 here. And also second condition. So f of x and integral finite and also single valued function. This is the second condition. Single valued function in the interval c comma c plus 2l. And third condition, what is the third condition? That is a very important condition. F of x is a piecewise continuous, or sometimes it is called as sectionally continuous. Piecewise continuous in the interval c comma c plus 2l. And fourth condition, f of x has the maximum and finite number of maximum and minimum. Maximum number and minimum in the interval c comma c plus 2. So these four conditions are satisfied, then the function, given function f of x can be expressed as sum of sine and cosine waves. For example, I consider the example f of x is equal to sine x in the interval 0 comma 2 pi. So the first condition, you know that the f of x sin x is the periodic function. The condition number 1 is satisfied. And f of x is the finite value. So the maximum it is 1 and minimum is -1. So it is a finite and it is integral value also finite, and it is also single valued function sin x in the interval 0 comma 2 pi. Condition number 2 also satisfied. And if sin x function is continuous function, it is a continuous function. If it is an infinite number of subintervals it is there, it check whether it is continuous or not. The function is sin x is a continuous function in the interval 0 comma 2 pi. So condition number 3 also satisfied. Condition number 4, what is a sin x has the finite number of maximums and minimums. 4 also satisfied. All the 4 conditions are satisfied. This sin x function expressed as sum of sine and cosine waves. And here I discuss some important results. Some important result. So the first result is, you know that what is the value of sine n pi? 0. Sine n pi value is 0. And what is the value of cos n pi? Cos n pi is equal to -1 whole power n. Cos pi. Cos L is equal to 1 case. Cos pi is equal to -1. What is the value of cos 2 pi? N is equal to 2. N is equal to 2. -1 whole square. Cos 2 pi value is equal to 1. What is the value of cos 3 pi? N is equal to -1. You understand? So if it is n is odd number, the value is -1. If it is n is even number, the value is 1. Cos n pi value. And also one more third result. The third result is, you go for back, the third result is the integral c to c plus 2 pi. Integral c to c plus 2 pi, or you can take the interval c to c plus 1 sine nx. Nx value, sine nx value is equal to 0. I will show this result. So take the integration c plus 2l sine nx. What is the integration of sine nx? Minus cos nx by n. The integration of sine nx is minus cos nx by n in the interval c to c plus 2l. So minus cos of n of c plus 2l by n minus cos of n of c by n. So here the cos x is a periodic function in the period 2l. This is equal to minus of here, minus of here, minus plus. So minus cos nc by n plus cos of nc by n. So upper limit minus lower limit, here minus of minus plus cos minus cos nc by n plus cos nc by n. So the answer is 0. So you remember that integral c to c plus 2l sine nx is equal to 0. And also one more important result, here I discuss integral by parts. You know what is a integral by parts? Use the eyelet condition. Eyelet condition. I for inverse, L for logarithmic, A for algebraic, T for trigonometric, E for exponential. So here eyelet. So by using eyelet condition, choose the values of u and v. So here I consider the one integral uv dx is equal to the formula u into integral of v dx minus integral of u dash into integral of v dx. This is the basic integral by parts of two functions. So instead of this one, I here give the one more formula for integral of uv dx is equal to uv1 v1. What is a v1 means here? Integration of v1 means integration of v with respect to x. v1 means integration of v with respect to x. What is u1? It is a differentiation of u. u suffix ఇక్కడ పవర్ లో ఉన్న 1 it is indicates for d by dx of u, differentiation of u with respect to. So what is a v2? v2 means integration of v1 with respect to x. What is u power 2? It is the d by dx of u1. So in the power of 1, 2, 3, it is indicates for differentiation. In the below power, superscript and a subscript. Subscript is indicates for integration. Superscript indicates for differentiation. Let us take one example. Here I want to calculate the integration of x square sin x dx. This is the example. So how do you apply the integral by parts? Instead of that one, I use the shortcut formula. So it is integral uv dx is equal to, already I written previously, in u into v1 minus u dash v2 plus u2 v3, alternate symbols, minus plus minus, minus u3 v4 plus so on. So it is this formula continue until your differentiation value of u is vanish. Let us see. So here I consider it is the algebraic function x square. I consider u, that is the first one. After that, trigonometric function v, I consider. In this case, I start the formula u. What is u? X square. Ux square. What is a v1 indicates for? Integration of v. What is the integration of v? Sin x integration is minus cos x. Integration of v is minus cos x. Minus, and differentiation of second function. What is the differentiation of second this one? U differentiation with respect to x. X square differentiation is 2x. This function differentiation, u differentiation is 2x. u1 means u divided. And v1 integration is called as v2. v1 integration is called as v2. Minus x minus cos x integration is minus sin x. Minus cos x integration is minus sin x. Plus, after that symbol is plus, and differentiation of u2, and it is means this 2x differentiation, this term differentiation, 2x differentiation is 2. And after that, what is the integration of minus sin x? Minus sin x is minus cos x. Minus of minus plus cos x. So this one. And after that, symbol is minus. What is the differentiation of 2? This differentiation is 0. The first term is differentiation, second term is integration. First term is differentiation, second term. So the previous term, 2x differentiation is 2. Minus sin x integration is minus of minus plus cos x. So here the first start from u means x square, and second term is integration of sin x minus cos x. After that, symbol minus. There was first term, next one first term 2x, and next integration of this one minus sin x plus 2 and integration. So this continue until your the first term, and that means u term, it is constant. And after taking the differentiation of this 2, it is 0. And we take one more example. So it is considered as x cos x dx, very simple one. So the first one, again apply u. What is u? X. V. U is x, v is cos x. It is cos x, integration of cos x sin x minus the first here x, this is a u1 means differentiation of u. So x differentiation 1, v2 means integration of v1, sin x integration cos x, plus 1 differentiation 0. So stop here. So this is the value of integration of x cos x dx is equal to x sin x minus cos x. And also remember one more formula, integration of e power ax sin bx dx is equal to e power ax sin bx is equal to e power ax by a square plus b square a sin bx minus b cos bx. So remember these formulas, it is very helpful for solving the Fourier series. And one more formula, e power ax into cos bx. Integration of e power ax into cos bx is equal to e power ax by a square plus b square a cos bx plus b sin bx. A cos bx plus b sin bx. So this is the today topic. Today I will discuss what is the importance of Fourier series and the basic conditions that are called as Dirichlet conditions, and also some basic formulas is useful for solving the Fourier series. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.